Hello everyone, this is Namita from the Department of Civil Engineering, ATMSC Mysuru. Today I am here to explain about the properties of minerals. And basically you have to learn and you have to know what is mineralogy and what is a mineral. So mineral is defined as the naturally occurring solid inorganic and homogeneous substance with definite physical and chemical properties. And mineralogy is nothing but it is a study of the properties of minerals. So those properties includes both physical, chemical and as well as optical properties of minerals. So guys, actually these minerals are not going to be same for all. So we have classifications of minerals based on the compositions. See, for example, more than 5 classifications we have done based on the composition. See, for example, first classification is oxide group of minerals, so based on the Si content, and the second is it may be a carbonate group of minerals based on the CO content, that is calcite content or calcium content. And also we have a iron oxides or a classification of minerals based on the iron content. So like that we have a classifications based on the composition. So here today I am here to discuss about some of the group of minerals. So for example, here I have shown a quartz group of minerals with their properties. Because the complete explanation regarding the physical properties and as well as the complete characteristics of each group of minerals you have already discussed and as well as you have already known from the theory section. But here some of the properties were only defined in the theory section, but practically you people have not done, it seems. So for that purpose, each and every properties I am just going to explain one by one. And before going to that, I have placed some more hand specimens here. So these all the quartz group of minerals which comes under quartz group, means the varieties of quartz which comes under quartz group. See, for example, here we have our transparent quartz, and here smoky quartz, and this is the quartz, and this is the one that is milky quartz, rosy quartz and rock crystals. So these are the varieties of quartz specimens what we have here, which comes under quartz group of minerals. And here if you observe the hand specimen, generally by visually you will come to know, and also you can say that the properties of each quartz group mineral is going to change. But I'm not saying that all the properties are not going to change, but only some properties. See, for example, chemical composition will be stay safe and stay same, that is SiO2. Habit is going to change because you observe here, so this is completely different from this smoky quartz and as well as this. So if you observe any two specimens or any two hand specimens, you will come to know what is the habit of that particular mineral sample. So like this, the first property is habit. So this is going to change from one specimen to another. And also the major thing is, by observing these specimens, the first thing which will catch your eye is color. So color is also going to change from one mineral to another mineral. That is what you can observe here very clearly. So this is quartz milky, means completely you can observe the milk white. And here rosy quartz, you can observe some light pink color, and here smoky quartz, a smoke gray color, and this is completely transparent, we can say it as a colorless, and also this is some gray. So this is how the color and also as the streak, or it may be the habit, like this. Some of the properties are going to change from one mineral specimen to another mineral. So that is what I'm here to discuss about the physical properties. So as you know, and as well as all of us know, the properties, we have more than 13 properties for a mineral. So first we'll come one by one. First we'll start with the chemical composition. So chemical composition is same for all the specimen, that is SiO2. And next property is, that is what I have shown here clearly. So that is chemical composition, habit, color, streak, luster, hardness, cleavage, fracture, specific gravity, the affinity, classification of each mineral, uses and particular name of the mineral. So these are the properties of a mineral what you have to understand and you have to identify in the laboratory, particularly in the geology laboratory. So if you start with the first property, that is chemical composition, that chemical composition is same for all the specimens, that is SiO2. And second, if you comes to the habit, so as you all know, the habit is also going to change because some of the specimens are going to have a crystal habit and some of them are having a massive or earthy habit, or it may be crystalline. So like this, habit is going to change. And also the habit of a crystal is going to vary because some of the minerals are going to having acicular, or it will be like a fibrous habit, or it may be micaceous or pigmatic. So like this, prismatic. So these like this, the habit of a crystal is going to vary. But here usually most of the quartz samples or quartz specimens, what we will get it in the nature. So those habits will be will be crystal, and some of the minerals only going to have a massive habit. And before going to describe the habits or before going to differ the habit from one specimen to another specimen, you have to understand the difference between massive and crystalline. So what is the difference between crystal habit and what is the difference between massive habit? Because these all the things we already came across with in the last semester, that is in the third semester itself, when you people were discussing, or when you people were studied regarding the theory section of geology. So on that particular time you already get a knowledge, or you have already gained the knowledge of geology. So based on that, practically you have to implement here, means how can we differ the color from one specimen to another, and how can we differ the streak, like this. So the habit is over. The first, this is what quartz transparent. So here you can observe this is completely crystal. So crystal habit you can observe here with the sharp edges. So like this, sharp edge. So this is completely crystal or crystalline. Yeah, this is, and here also you can observe this is quartz rock crystal. Yeah, so this is the one. And next we'll come to the color. So as I mentioned in the beginning itself, the color is also going to vary from one sample to another sample, and also you people can observe this. So this is smoky quartz. So in the sample name itself, they have already mentioned it is smoky gray. Yeah, so based on this color, they have named it as a smoky quartz. So the smoke gray color you can observe here. Yes, so this is smoke gray color. And this is completely colorless because nothing can be observed here, means the color. And another one sample here, this is the one you can observe. So this is rosy quartz sample, a light pink color. So a light pink color you can observe. Yeah, so this is rosy quartz. So like this, the color is going to vary from one sample to another sample. That is what I am shown here. And the second, next is streak. So when you people were discussing regarding the properties, you have heard about the streak. So streak is nothing but small substances which is obtained on the streak plate when you scratch a mineral. See, for example, so this sample I'm going to take, this is smoky quartz and this is the streak plate. Usually we will be using in the geology laboratory. So streak is nothing but a small powder like substance which is obtained on the streak plate when you scratch a mineral on the streak plate. So if you scratch a mineral on the streak plate, so if any small powder like substance, if it is obtained on the streak plate, then we can say it as a streak is present. So after that you have to analyze which color is obtained. See, when you scratch a mineral here on the streak plate, you have to observe whether the small substance is obtained, a powder like substance is obtained or not. So if it is not obtained, you can say it as a streak is not obtained. If it is obtained, you have to analyze whether it is in a white color or it may be in some other color. So these are some of the examples which we got it from some other samples. So this is how the streak is going to obtain. And another one thing you have to keep in your mind that obtained streak color is always not same as the original hand specimen. So sometimes the original hand specimen color is different and the obtained streak color is different. So here from the smoky quartz, if you scratch a mineral by putting some force or some effort, will observe streak is obtained here. Yeah, so the streak color is white. So this is what you can observe, the streak color is white. So that is the fourth property of a mineral, that is streak. So from the quartz group of minerals, we are going to get the streak. So that streak will be in white color. And next we'll go for the another property, that is luster. So luster is nothing but appearance of the hand specimen when you expose to the sunlight. So if you expose any one of the sample to the sunlight, so how it appears or how the reflection of light is going to be. So whether the reflection is more or whether the refraction is more. So based on that, how it is going to appear and also how it is going to give the shininess. So if you expose a mineral or a sample of a quartz mineral to the sunlight, if you get some shininess on the surface of the minerals like this, so that is considered as a luster is present. But here we have a different varieties of reflection of light and as well as different varieties of luster. So whether if you get the shininess from all the edges and from all the parts like this, from each and every angle, if you are going to get the shininess on the surface of the mineral, then will be considered it as a vitreous. So sometimes the shininess is going to appear on the surface of the sample with like a dots. So that is pearly luster, like a pearls. So how the pearls are going to be shine. So like that, if you get it on the sample, then will be say it as a pearly luster. So like this, the luster is also going to vary. So here the complete group of quartz group of minerals are going to have a same luster. So this is also, so if you expose, yeah, like this. So if you expose a sample to the sunlight, then you will get a shininess in all the angle, everywhere. So yeah, so everywhere the light is going to reflect and also you are going to get a shininess. Means the shininess can be absorbed here on the surface. So this is about luster. So all the samples or the minerals or the varieties of quartz which comes under a quartz group of minerals will be having a same luster, that is vitreous. But sometimes in some of the samples you are not going to observe very clearly because of the dust particles. So as you can observe here. So here if you wash it properly or if you remove this the sticky ones, so then it will be very clear. But here you will be having some of the dust particles which is stick here. So because of that, sometimes you are not able to observe the luster and the hardness according to the standard scales, that is Mohs scale of hardness. This quartz will be lies in the 7th place. That is what we are considering hardness is 7. And next is cleavage. So cleavage is completely absent here in the quartz. But means all the varieties of quartz is not going to have the cleavage, but the other group of minerals are going to have the cleavage. So cleavage also will be depends on the nature of the mineral and how it was formed. See, for example, if you so for example here, so this is, as I mentioned here, that is transparent quartz. It is completely transparent, and here the cleavage is absent. Yeah, you can observe. And next we'll come to the fracture. So fracture is here in the quartz group of mineral, that is conchoidal. So basically fracture is nothing but the surface of the broken mineral other than the cleavage plane. So surface of the broken mineral. So once you break a small part of the specimen here or somewhere else, so how the surface is going to appear in the broken place. So exactly where you are going to break the mineral. So after broken, you have to observe the surface. So how it is going to be appear. So whether it is a even fracture, uneven, conchoidal or earthy, like that. See, for example, when you break a mineral completely, if it is going to have a flat and smooth surface, will be say it as a even fracture. And uneven fracture is nothing but when you break a mineral, so that broken place surface is going to be irregular. It is not going to be smooth and flat. That is uneven fracture. So whether it is a even, uneven or conchoidal, you have to analyze. So conchoidal is nothing but basically this quartz group of mineral is having a fracture conchoidal. So conchoidal is nothing but fracture is made up of a concave or it may be curvature with a convex shape. So if you break a mineral here or somewhere else, so the surface is not going to be smooth, but the broken surface is going to have a curvature. So those curvature will be concave or it may be in a convex. So the curvatures, a small rings can be observed on the surface of the broken area. So that is fracture, and specific gravity is 2.6. So specific gravity, as you know, the weightage of a specimen in a same volume of water, and diaphanity. So this is the special property of the quartz, you can say, because diaphanity is going to change from one mineral to another mineral, because diaphanity is nothing but basically transparency of a mineral. So here, if you take a quartz crystal or crystalline quartz, you can observe it is completely transparent. Means if you make a slide of this, you can observe an object through the mineral what you have in front of this. So you can observe the object through this very clearly. So that is the reason. So this is called as complete transparent quartz. And if you take this rosy quartz, so here also diaphanity we can consider it as a transparent to translucent, because as you all know, diaphanity is going to lie on three properties, or we can say it as a three elements are there in the diaphanity, or three types. One is completely transparent like this, and another one is translucent like this, and the third type is opaque, means complete dull or earthy. So this is transparent completely, you can observe the object through this, and this is translucent, means only through the edges the light is going to reflect. So that is the reason, only through the edges you will be able to observe the object. So through this edges, so only through this edges you will be able to observe the object. So that is what we can say it as a translucent. And the last is opaque. So opaque will be something like this, because all the quartz minerals will be having affinity transparent to translucent only. How the opaque will be, how the affinity opaque will look like in the hand specimen, that I will show in the next group of mineral, because almost all the minerals, that is quartz minerals, will be having a transparent or translucent affinity only. And the next property is classification. So because of the composition, that is SiO2, all the quartz group of minerals will becomes under oxide group of minerals. And the uses, the major thing is uses of quartz group of minerals. So that is what you people have to understand better, because you will be knowing some of the uses of the rocks, where it is going to be used during the construction and all, but you may not knowing about the uses of each and every group of minerals. So that is the reason you have to understand it better. And all the quartz minerals are going to have its special properties and as well as special uses. See, for example, this kind of complete transparent quartz minerals are going to use for the manufacturing of glasses, window panels, and also for cutting optical instruments they are going to use, and also to make the lenses for microscopes and all, they are also going to use this transparent quartz. And smoky quartz will be used for the manufacturing of watches and also pre-stressed concretes. Particularly if you are focusing the uses of minerals or rocks in a civil engineering field, then you will be absorbing this. This smoky quartz uses pre-stressed concrete. So in the pre-stressed concrete they are going to use, and this is milky quartz, it is going to use in the agrogranulars. So like this, except individuals, the complete quartz group of minerals are going to use in the making of jewelry as a gemstones. And this quartz has been used in jewelry shops for the production of jewels and as a gemstones, and also the manufacturing of glasses, window panels, clocks, watches, and also foundry materials like a metal casting industry, means particularly in metal casting industry they are going to use, and also in refractory industries they are going to use. And this is means the quartz samples are going to use for the making of sandpapers, and also used as abrasives, petroleum industry, and also it is going to use as a tool for sharpening. So these are the major uses of quartzes. And also the each name means different varieties of quartz I have mentioned here. I'll be not able to have the complete different varieties of quartz. How much is necessary, and also what are the major things can be observed from each and every specimen, that is what I have mentioned here. So these are the major physical properties of quartz group of minerals.